Yeah, my friend Amita will continue.
Thanks, Sai. Now I'm going to explain about keyword search. In this, we have used an inverted index builder, which is an index data structure used for storing a mapping from content. This concept we have implemented for keyboard search. Next, tokenization, which is the process of splitting a text into a list of tokens to extract only words. The ranking class, which is used to sort keywords. So that it retrieves the top 5 matches and number of items it has occurred in the given file. To retrieve this matches hash maps, which is to store the items in a key value pairs, and you can access them by an index. The put and get operations of hash maps takes the constant time, though it depends on the lots of factor and hash functions. The time complexity of this hash map operations is omega of n. Next. To generate we have used binary heap. The algorithm of this binary heap is start and next build the index using the binary heap and retrieve the binary heap which corresponds to the keyword and print the top k results using the min method and stop. Next, Smiley will conclude this. Hello everyone. This is Namrata. Today we are going to present about our project search engine called Surfer. Our team members are Smiley, Sai, and Vinay. The contents of our presentation: objective, features, roles, implemented concepts, feature scope, conclusion, and references. The main objective of this project is to understand the course lecture and implement those lectures in our project, which includes the concepts such as JSOOPs, hash maps, search trees, or spell checking keywords. The features of this project is to provide flawless user experience to the end users in the keyword search and to provide useful suggestions for faster search and also enable the faster and auto-enabled check. The concepts which we have implemented in this project are JSOOP, inverted index, ternary search try, binary heap, dynamic programming, edit distance algorithm, and delete min method. This is our contribution to this project. Next, Sai will take over this.
Hello guys, this is Sai here. So I'm going to explain you about the pre-processing activities in our project. So in our project, basically to implement any of the main feature, we need to have some active pre-processing activities implemented. And there are mainly 4 steps in the pre-processor. One is converting HTML to text using JSON, and then build a record level inverted index using nested hash map, and then restructure inverted index to use binary heap, and then build a TST with all the words which we got from our previous step. Actually, for this converting HTML to test, we will be using JSOOP, and JSOOP is a Java library, uh, which is which is used to pass HTML document. It provides API to extract and implement data from URL to HTML file. And for inverted index, it's a hash map like data structure that is used to store a mapping from content such as words or numbers. And inverted index is of 2 types. One is record level inverted index, and second one is word level inverted index. And the only difference between these two is word level inverted index consumes more space and more time. That's why we'll be using record level inverted index in this project. And most popular data structures used in document retrieval systems used on large scale, for example search engine, is this inverted index itself. And we have some disadvantages using inverted index, that is it it consumes large storage, and the maintenance is very high when we want to update or delete or insert anything into this. And after this, all the uh, all the words which we got from binary heap will get stored in a TST, that is ternary search trie, and TST is a compact representation of a DB trie, and it has a constant character C and then three links. And in these three links, all the values or keys which are less than C will go to the leftmost side, and in the middle link, all the keys which are equal to C, and in the rightmost link, all the keys which are greater than C will go. And then it is the more efficient DB trie. And
hello everyone, this is Smiley. Today I'm here to give you a brief explanation on our module suggestions in our SUP application. So I'll just give you a brief idea on how the suggestion module works. So whenever you give or search a keyword in the web search engine, then it will just provide you a sample like for like the related words regarding it, right? So similarly, we have implemented the idea. So whenever you give a keyword, suppose in the screenshot you can see attached, you can see we have given a keyword Java. So if the Java that keyword gets matched with the input files we have presented in our text, then it will give you the related words. And if the keyword is not matched with any kind of text in our files, then it will just give you the time consumed for getting the suggestions. That will be in nanoseconds. So in the suggestion module, we have implemented ternary search trie concept. We have mainly included this concept because it was space efficient, so that compared to other tries, it is very space efficient, so that it will just follow the standard prefix trees at the cost of speed. So ternary search trie, it is a type of trie where nodes are arranged in a manner similar to the binary search tree, but binary search tree generally has two children, but here in the ternary search trie it has three children. So this ternary search trie is used as an associative math structure with the ability of incremental string search. And here the time complexity for the ternary search trie is the average will be like for search and insert operations, it will be big O of log n, and for the delete operation, the worst case complexity is big O of n. And coming to the tries, this ternary search trie is rather slower than other prefix tree, but this can be better suited for larger data, so due to the space efficiency. So here we have even included the hash maps also, so that in the place of for mappings the string to the values. So this is a sample algorithm where it resembles our code. So generally you start the code, you start with writing a module, and there the initial step will be it will convert the contents of the file to a string, and then you just substitute identifier in the place of string, and the ternary search tree will get that operations will get work. And if the keyword is matched with any kind of words in the file, then it will show you the output. And Vinay, can you please carry on further?
Thank you, Smiley. This is Vinay. I'm here to talk about the spell checker. As we know that every search we made consists of spelling mistakes knowingly and unknowingly. So it has to be spell checked before we get the appropriate result. For this, we use TST feature for checking the spelling. And we also use the method called edit distance, which has a time complexity of big O of nm. So here you can see the example where if I have given a statement that says JAM, it is asking to me again like they do in the Google, like JA. And if you go to the second example or third example, the same thing is repeating because there are spelling mistakes and the word is not matching with the dictionary, right? To match the word with the other word, we use a method called edit distance. In edit distance, it is a concept To understand edit distance, we can consider two strings, A and B. Edit distance is the minimum number of changes required to transform the word A into the word B. To perform this efficiently, a table is maintained for the previously computed substrings and used to calculate large substrings. This is a concept of dynamic programming. Dynamic programming is nothing but it is a process of breaking the complex problems into small problems. It is a bottom-up approach, and it has three steps. We can say steps. First, the concept is recursion. The other one is store, and the other one is the bottom-up. So recursion is nothing but, as we all know, the function calling itself. So, and we also have the store option. This is where the dynamic programming comes into the picture. So, to avoid computing the results once again, we store it in a specific variable. And we also use bottom-up approach, which means the specific to general. Specific is nothing but solving exact similar small problems and computing them to solve the major problem. The major difference between recursion and dynamic programming is recursion is a top-down approach, and dynamic programming is a bottom-up approach. We can also compare the complexities of recursion and dynamic programming. The complexity of recursion is big O of n log n. The complexity of dp is big O of n into 1. So by this we can understand how the dynamic programming makes a difference here. Here we could be in the dynamic programming, to conclude, I also want to say about the uses of it. So if you take the example where you store one word and you understand that the other people keep searching the same word, to avoid this computation time, it will store it in a variable, so it can be reused. That is the end of the concepts we developed. Coming into the future scope, and we did some part, and I can understand there are so many things that we can take into the consideration. So in the future scope, we can use it for large dictionaries and data sets. It is used for implementing redirection feature, integrating across all devices and the Internet of Things. We can also include voice search as an option, so we can avoid typing and the user can give the commands with his voice. To conclude this presentation, I want to say that we have learned the above data structures from the class lectures and implemented them in real time, and we also did our own research to dig deep. We have learned different concepts like JSOOP, inverted index, binary heap, ternary search tree, and edit distance. As I mentioned earlier, as we did our own research, we can say that there is a lot of scope to add new features moving forward, and the user experience while using a search engine changes a lot in the upcoming days. These are the differences we take into the consideration before preparing this presentation. And thank you for your time, and thank you for listening to our presentation. And if you have any questions, you can drop it in the comment section. And thank you so much. Thank you. Have a great day. Bye.